managing this complexity feels quite overwhelming. Whereas when coming to cloud, you want your infrastructure to work flawlessly, ride the cloud. Managed instance groups on Compute Engine help you handle all of the problems above automatically and build highly available and scalable applications, and also roll out the updates automatically and safely for you, so that you can have a peace of mind knowing that your application is well taken care of. Today, we're going to talk about how to build your applications on top of managed instance groups, how to deploy them, how to build scalable and highly available stateless load balanced application, and also how to scale a batch pool of workers. And if you are already familiar with the managed instance group, we have some pro tips for you. So let's start. First, from the application deployment. You have your continuous integration, continuous deployment pipeline that produces a software build at the end. And you could package this software in 3 ways. Into a container image. You could bake a boot image with all of your application and libraries pre-installed. This could maybe give you a faster startup time. Or you could use a simple startup script that would install your dependencies and software on a VM boot. Any of these methods work with managed instance groups. However, for this presentation, let's look at an example of how would you deploy application in a container image. It is very easy. It only takes 2 steps. First, you create a virtual machine, and then you check the checkbox that you want to deploy a container to this machine, specify your container image and Docker runtime parameters. For example, a restart policy, or you could pass some environment variables to your container. And that's it. What will happen next is that Compute Engine will create a virtual machine for you. This machine is going to be based on a container-optimized operating system that has Docker pre-installed and also a container startup agent that will start your container on VM boot. So you don't need to write any scripts to start the container yourself. And in addition to all of that, the container-optimized operating system image is supported and maintained by Google, so you can always use and get the image with the latest update and security patches to create your new machines. And if one VM is not enough, you can create a group of machines with the container. First, you would create an instance template from a container image. And then you would create a managed instance group from this template that would then scale and create as many VMs as you need. And if your application needs load balancing, you can attach it to a load balancer. Let's look at how it works in practice.
OK, so first of all, we need to put a template, a container into a Google Cloud registry, Google Container Registry, so we could then use it. So you can do it with a simple Docker push command. So let's go to the container registry. I've put a container before the presentation, so let's copy the path to the container. And now let's create a template. So Compute Engine, templates. Let's call it a container, GCE. Let's provide an URL to a container. And let's allow HTTP traffic because our container has a simple web server that is serving applications, so we can verify that it works after it's been boot up. So now we have a template ready. So now let's move to the instance groups and create an instance group. So let's choose a zone. Now we have to choose a template that we've created previously. We can turn off autoscaling for now. It will not be used. We can set any number of instances that we want and create. So now we can see that managed instance group is being created. So it usually takes a little bit of time. So refresh, it should be ready by now. Yeah. And we can already see that managed instance group is created and it's scaling up. So let's go here. We can see that all the 3 VMs are up and running. But remember that we have a container, so the container needs to be downloaded, set up, There is also a fire rule. So if you want to look at the details, what's happening inside the VM, you can go to the serial port console. And we can see that the IP table rules are being set up. Now it's pulling the container from the registry. You can see that the container is being downloaded. Then it's being set up, so it's up and running. So let's verify if everything works. And it's ready. Back to you, Mikola.
So in this simple demo, we have deployed a stateless application on multiple virtual machines. Now let's look, how do we make this application highly available and scalable? First, a good example of a stateless application would be a web front-end such as online store. You want it to be highly available so that your users don't get HTTP 500 when checking out while shopping. And you want to be scalable so that you can get all the business that comes your way on Black Friday. And it's worth noting that stateless means that you manage your machines like a herd of sheep. You care about the size, but you can easily replace one machine with another. They all do the same thing, and they don't preserve any state past VM lifetime. So let's go back to the problems that we have discussed in the beginning. What to do when your application may stop responding or crash? Managed instance groups offer AutoHealing for that. It promptly detects machines with failed application and recreates them for you automatically so that users are served again. And you don't need to get a page in such a situation. It's all handled. AutoHealing is configured very easy. All you need to do is to configure a health check for your managed instance group. The way the health check works is that it pings each machine on a specified path and protocol and port, let's say my app HTTP 80. It pings it on regular intervals, let's say every 5 seconds, and it expects HTTP 200 response within the latency that you predefine. And if the response is not HTTP 200, or if it takes longer than 3 seconds, then the health check is considered failed. And if this health check fails multiple times, the VM is considered as unhealthy and will be taken care of or recreated by AutoHealing from the instance template where you have your well-tested and stable configuration so that it can serve your users again. It's also worth noting that health check not just works with HTTP protocol, but also with HTTPS, TCP, and SSL. So it can be configured in a very flexible way. Now, load balancer also uses health checking service that is configured in exactly the same way. The difference, though, is that load balancer does not send new traffic to the virtual machines that are unhealthy and sends traffic to the machines that are healthy, while regional or managed instance group would recreate a machine that is unhealthy, which is very different. For that reason, we highly recommend using different health check for a load balancer and managed instance groups. Imagine a situation when you have a machine that is serving at full capacity, so it cannot receive any new connections and would be unhealthy from a load balancer perspective, so that load balancer needs to redirect traffic somewhere else. However, it is still healthy from the instance group perspective because it is still serving well its current sessions, the application is up and running. And if you configure a more aggressive health check for a load balancer, let's say you do shorter check intervals or shorter response timeouts, you will allow load balancer to redirect traffic to less busy VMs. At the same time, AutoHealing will wait a bit and will let the VM finish the current sessions and become available again before it makes the final decision to recreate the VM. Another tip for you is make sure to set initial delay for AutoHealing to longer than it takes for your application to start serving. During the initial period that starts when VM is created, AutoHealing will not recreate machine even if it is unhealthy. This is to let your application time to boot. And of course, while it's starting and initializing, it's not serving, so it's not going to pass any health checks, and you don't want it to be recreated by AutoHealing. So if you set the initial delay to a higher value than it takes for your application to boot, AutoHealing will only recreate your VM if it is unhealthy because application has failed and not because it just hasn't started yet. Let's look at how AutoHealing works.
Okay, so we have our instance group. Let's look at how it looks like. So we have two VMs. Before I will show you how the AutoHealing works in practice, I need to clarify some things about this web server application. So this is written, as I said, for the purpose of this presentation, and it has two functions built in. The first one is reporting the health status. So that will be used to verify that the VM is healthy and is serving. So we can verify by clicking here that it returns response to 100 and it's serving. So what I've done is I've put a simple command that will disable the health track. So it will make VM stop reporting the health status. As you can see, this is not working. So what now AutoHealing does is it pulls the health status from all the VMs inside the group to verify that the VMs are healthy, up and running, and everything is working. And if it looks, and if it detects that VM is reporting 500 or the application stops responding, it will recreate it. We can also look how AutoHealing is set up. So you go into the Cloud Console, health checks. We have an AutoHealing. So as you can see, we are looking at the path health, so the same as I've shown you before on the application. It's using protocol HTTP, but you can use TCP, HTTP, SSL on any port you want. You need to specify interval, timeout, the number of consecutive failures, etc. So let's go back to the instance group. And as you can see, VM has been detected that it's failing, so it's being recreated automatically by the managed instance group.
All right, so now we have a group of virtual machines that are running, and if an application fails, it will be automatically detected, and the VM will be recreated by AutoHealing. Great. But what if a bigger problem happens and the application fails in an entire zone? In this case, AutoHealing won't help because the root cause of the problem is likely not on a single VM, but is related to zonal configuration. So to protect your application against such a situation, you would use a regional managed instance group and distribute your machines across multiple zones so that should a single zone fail, your application can still serve from the other available zone, and the load balancer will redirect traffic to the healthy virtual machines in those zones. You can note here on this picture that, however, you will get only 2/3 of your capacity remaining in the case of zone failure. And if you care about your high availability so much that you want to have enough machines to serve your expected load, even in case of zonal failure, you should make sure that these 2/3 cover that requirements. And in this case, you would need to provision extra VMs. Let's take a look at the example. Imagine, like at this picture, you need 9 VMs to serve your traffic. So in order to protect you against zonal failure and still have sufficient VMs, you need to create more extra VMs so that should a zone fail, you have, in this case, 10 VMs available, which is more than 9 and enough to cover your expected load. Calculating how many VMs you need to over-provision to protect your workload against zone failure is easy. All you need to do is to divide the number of the VMs you need by the number of the remaining available zones. So for example, if you deploy your group to 3 different zones, you need to add 50% more VMs that you regularly expect from your workload. This way, you would protect it. Let's see how a regional managed instance group work.
Okay, so let's go to our regional managed instance group. So as you can see, we have 3 zones, B, C, and F. And each zone, we have 2 instances up and running. So there is also a load balancer configured. So you have to go to networking services, load balancing, and the load balancer. And here is the IP of the load balancer. So we can query the load balancer and see that on each refresh, different VM is serving. So this application gives you, as you can see, the host name, the zone that the VM is in, and the template is used, that it will be used for the purpose of the later presentation. So what I've done, I've written a simple script that will query the load balancer, like query all the VMs and get the current zone that the VM is in, and we'll report it on the screen. So let's run it. So as you can see, all the VMs are up and running, or are serving from all zones. So now what we can do is like simulate the zone failure. So of course I will not bring down the zone during the presentation, but I can simulate it by disabling health checks, disabling making the VMs report unhealthy status. So let's do it. So that's regional, disable, US Central 1, and let's disable zone F. Like disable the VMs in zone F. Yeah, there is Central. Okay. So now the health check is configured the same as in previous demo. So we need a few seconds to load balancer to see that the VMs stop responding. As you can see, it happens quite fast. So now our traffic is served only from zone B and zone C. So let's bring down another zone. Let's wait for a few more seconds. And as you can see, only VMs from zone C are serving. So now let's bring back all the zones back. So what happens is AutoHealing, the load balancer queries the health status of the VMs, and if VMs start reporting that they are healthy again, it will redirect traffic back to those VMs. So as you can see, we've got already 2 zones up and running, and the third one will be brought back in a matter of seconds. Back to you, Mikola.
All right. So now we have a group of VMs where if a single application fails, it gets automatically recreated, and it is protected against zonal failure because the VMs in the other zones can still serve. Back to the problems. But what if a load spikes and lands on insufficient capacity? You don't want to lose business because of that. Or what if a load goes down and you have idling VMs? You don't want to pay extra for those. Autoscaler of the managed instance groups makes sure that the group has enough instances to serve the load that you have and adjust its group size in real time. Configuring autoscaling is also fairly simple. You turn autoscaling on in the managed instance group configuration, choose the scaling metric that you want to use. CPU usage is a very popular one. Select the target load for that metric, for example, 60% CPU utilization on average per single machine, and specify constraints so that autoscaler does not scale beyond these boundaries, the minimum and maximum. Let's say you want your group size to be at least 1 VM, but not exceed 10 instances. And one more important parameter is cooldown period. This is how long an autoscaler should wait before taking a machine into account since it started booting. This is important because while VM is booting, it might have boot processes that highly utilize CPU and which is not representative of the regular serving load and could create a noise for autoscaling signal. So if you set cooldown period to longer than it takes for your VM to boot and stabilize, you will make sure that Autoscaler will ignore these boot-in instances while they're loading, and without this noise from the signal, and as a result, get more accurate group sizings by the Autoscaler. Let's see how autoscaling works. Imagine you have a group where the load spikes, and in the current number of the VMs, the CPU usage goes significantly above your target, which is 60% in this example. Autoscaler will detect the situation and add more VMs to bring the average load back to the target value. And when over time the load goes down and becomes lower than your target, Autoscaler will also detect the situation and will remove the extra VMs, again, to bring the load back to the target. A pro tip for you is if you want to accelerate your scaling, you should set up a lower target value for it to maintain. We can look at this as an example. Imagine you have 3 VMs, all of which are overloaded. One is at 80% CPU utilization, 70 and 90. And if your target is 60%, the Autoscaler will resize it to 4 VMs. And if your target is 40%, the Autoscaler will resize it to 6 VM, which is a faster scaling that you could achieve. Also, if you use Autoscaling together with regional managed instance groups, make sure that you set a higher maximum load than you expect for your maximum demand, higher maximum number of instances than you expect for a maximum load, so that Autoscaler has enough room to scale up should a single zone fail. This is exactly the same formula that you would use for a non-autoscaled group. The only difference is that for the non-autoscaled group, this formula would be applied to the target number of VMs, and these extra VMs will be actually running. Whereas in the autoscaled scenario, you would apply this formula to the maximum boundary for the group size, and the group will reach maximum only when it is needed in those zones. So let's see how autoscaling works.
Move into the instance groups. OK, so we have an instance group with only one VM that is serving the application, the web application that you've seen before. So, as I said, this web application has 2 functions. One is making VMs reports unhealthy status, and the second one is generating the high load on the CPU. So what it does in the background is multiplying 2 random numbers in a loop. So we'll have high CPU utilization. So let's start the function. So in the meantime, that we'll wait for the autoscaler to kick in, let's look how it's set up. So let's open the autoscaler. So we have a autoscaling setup based on the CPU usage. I've set up the target CPU size to 30%. So the autoscaler would spin up VMs a little bit quicker for the purpose of this presentation. I set up the maximum number to 5, and the cooldown period to 15 seconds because the web server is like a simple Python script, so it takes like a few seconds to start up. So let's go back. So as you can see, autoscaler is already detected the high load on one of the machines and brought up the additional VMs to compensate the load.
All right, so now we have a highly available and autoscaled group of VMs. But how do you handle updates? How do you roll out updates in a safe way, making sure that your users don't experience downgrade of your service? Auto-updater allows you to roll out an update in a safe way and in multiple different scenarios and do it automatically. When you do an update, you want to, at the end of the day, get your group from an old version to a new version. And the actual update is all about the journey from that. And you can configure this and automate this journey with the following configuration options for the auto updater. The first one is you set up how far would you like to roll out the update. How many machines would you like to update? You could decide that you want to update half of the machines or maybe the entire group. The second option is how many machines do you update at a single time. To roll out the update carefully, you don't necessarily want to update all of them at the same time. You want to update one or two, check if that they work, and then proceed. The third option is how many extra machines do you want to create in the new versions temporarily. This is useful when you don't want to take any of the serving machines in the old version down for an update and would rather keep them serving as they are, create the machines in the new version on the side, wait until they are healthy and start serving, and only then remove the old machines. You can also configure how long an updater should wait for the machine in the new version to boot and stabilize to make sure that it is truly healthy, and only then proceed to update in the next patch. You can also configure update action. By default, it is a recreation of a VM from a new instance template. However, you could also use a rollout strategy with the same instance template, but restarting the VMs instead. This is useful when update is actuated within guest operating system agents, such as Puppet agent, for example, on VM boot. And finally, you can choose update mode, proactive, which will roll out the update automatically, or opportunistic, in which case the updater will only create machines in the new version when new machines are really needed. For example, when the group is scaled up. And it will only remove the machines in the old versions when you need to delete the machines, for example, when the group should be sized down. So a pro tip for you is that if you want to update some specific machines at a specific time and do it manually, you could set up a new instance template for your group, set update mode to opportunistic, and then recreate those specific VMs at the time when you want it. Updater would treat recreation as an opportunity for update, and these VMs will be created from the new instance template. Let's look at what kind of scenarios you could build with this configuration. Rolling update is a very popular one. This is when you need to roll out a patch to your whole group or maybe a new feature to all of your users. So you want the update to roll out to the entire group, new template 100%. However, you want to roll it out safely. Let's say you want to update 3 machines at a time, wait until they are up, and if they don't pass the health check, stop the update. You can do debugging or maybe decide to roll it back. And if they do pass the health check, proceed to the next 3, and then the next 3, and so on until the whole group is updated. Another useful scenario is canary update. This is useful when you want to do A/B testing. Let's say you have an online web store and you need to roll out a feature that is expected to increase your conversion to sales. So you would set the new template to, let's say, 30% and wait for a week or a month until you collect enough statistics to make a decision whether the conversion has indeed improved and whether you should proceed with the further rollout or roll it back. The beauty of the canary update is that the managed instance group will keep this ratio for you as the group scales. You don't need to do anything extra on your own. So let's look at how updater works.
Okay, so we have a managed instance group that has 6 VMs. All the VMs were created from the first version of our application, so you can see that all of them have instance template number 1 as a source. So to make this demo a little bit more interesting, let's use another application that we've written for the purpose of the presentation. So it queries the VMs via the API and gets the current status of a VM. It can be creating, restarting, deleting, recreating, and it will also show you the version of the instance template that is used to create it. So as you can see, all the VMs are in version 1. So now let's do a rolling update. let's do a canary update with a rolling fashion. So let's choose that we want to have our second version of our application to be rolled out to 30% of our VMs. But we want to do it in a gradual way. So we want to only bring down one VM at the time and provision additional one VM at the same time. So we would not pay too much for the additional VMs, but at the same time, we'll keep the pool of the VMs in a stable way. So let's do update. And as you can see, the first VM started to be deleted. And at the same time, the second VM that we wanted to provision is already being created. So creating VMs is a little bit faster than deletion. So let's wait for a few seconds. It usually takes about half a minute. So as you can see, first VM is already up and running with the version 2 of the template. And as soon as second VM was created, another VM is being brought down, and we are just waiting for the first VM to be deleted. Once the first VM is deleted, we'll spin up additional VM, and the process continues. You can also verify here that the first VM is already, let's refresh. The UI console is a little bit slower than our application. So as you can see, this VM is being deleted. We already have 2 VMs with instance template 2. So here's one, here's the second one. And we can also verify that we have 2 VMs in the new version, and the rest 2 are being deleted.
All right. Another useful update scenario is a fast rollout without reduction in service. This is useful when you need to roll out and update your entire group. However, you cannot afford taking down any of the existing instances and would rather create them on the side. So you set the new template to 100% because you want to roll out the update to the whole group. You set max and available to 0 so that it doesn't update any of the serving old instances. And you set max search to 100%. In this case, the managed instance group will create the instances in the new version on the side, wait until they pass the health check and start serving, and only then will remove the old instances. As you can see, with all of these settings, you can build quite a flexible and automated update scenario that works for you. It will roll out the update if the new version passes the health check and is serving well, and it will stop the update and let you intervene if something is wrong and the new instances are not passing the health checks. Now, it's all good, but how does Updater work with AutoHealing? Could, for example, when you roll out an update and an old instance fails, could it exceed your max and available budget? The answer is no. Let's look at an example. Assume you set max and available to 2, and update started rolling out. It updated 2 VMs successfully, all good, but then old VM fails and is being auto-healed. Updater knows about it and reduces its max and available budget to 1, so it will only take 1 more instance for update, and at the end, you will get 1 instance updated to the new version, and the old instance auto-healed and serving. So Updater and AutoHealing work well together. How about Updater and Autoscaling? Could update rollout interfere with the autoscaling calculations? Let's look at an example. Let's say Updater took down 2 machines for an update. With the constant load, this would lead to a temporary increase in the average load for the remaining serving machines. However, AutoHealer is aware about these 2 VMs that are being recreated and will take them into account when calculating the desired number of the machines for the whole group. So it won't provision any extra machines beyond what you need and will wait for these machines to boot up. So Updater and Autoscaling coordinate their work and work well together. When rolling out an update to original managed instance group, updater will roll out the new version evenly across different zones to distribute the risk. And likewise, when removing the old virtual machines, it will also remove them evenly across the zones. Finally, when your managed instance group is load balanced and updater picks a specific machine to update, it will follow the following process. First, this virtual machine will stop receiving new traffic. Then it will wait for the connection draining timeout that is configured in the load balancer to let the current session that this instance serves finish in a graceful way. Then it will recreate the instance from the new template, wait until this instance passes health check, and only after that the new machine will start serving and will start receiving new traffic, and updater will proceed to the next one. So there we have it. We have built a scalable and highly available application on top of regional managed instance group that can be load balanced, and the group handles all of the problems that we've described above automatically for you. It handles VMs with failed applications with AutoHealing. It mitigates the impact of zonal failure by distributing your instances across multiple zones. It makes sure that the size of your group is tailored to the variable load that it might experience. And it also allows you to roll out updates safely and stop if you get the unhealthy new version. The main thing is that you can pick any of these automated services as you need, one of them or multiple of them or all of them together, and do the rest if you need your custom logic here. And in the end, have a peace of mind that your application is well taken care of. Now, let's look at how would you scale a batch pool of workers.
So what are the main characteristics of batch workload? So workers are not needed at all times because you need it only for the time of computation. So you can bring the workers down if you don't have anything to calculate. So you optimize mainly for cost instead of high availability, like in previous presentation. You also scale based on the number of jobs that are in the queue instead of, for example, CPU, because if you have computations to do, like they are usually very high CPU intensive. So scaling based on the CPU utilization would not be as good as the scaling based on the number of jobs. So to illustrate how to build a scalable pool of workers for batch processing, let's look at an example. So let's think about an image stock service. So usually how it works is like users upload their photos to our service, but before putting the images into the internet, we apply the watermark. So it's a perfect example of batch workload. So how architecture might look like. So a user uploads a photo through a client application. For purpose of the demo that I will show you in a minute, we save it into the cloud storage. When the image is saved, we also put the name of the image into the PubSub task queue. And then we created a managed instance group that looks for this PubSub queue, watches for the number of the tasks that are in there, and based on the number of the tasks, it will scale the application, spin up additional VMs. And we have a process that is running on these VMs that takes the images from the queue, the image names, then it downloads the images, applies the watermark, and then uploads them back to the cloud storage as an output. So how it looks like. So you have a small number of users that are putting images into the task queue. So we have small number of VMs. But if the traffic grows, so is the number of the VMs. But after you process all the images, all the tasks that are in the PubSub queue, autoscaling will delete all of the VMs, so you'll not have to pay for them idling. But if if there will be another pool of tasks put into the queue, autoscaling will pick them up and speed up additional VMs. So now let's take a look at the demo. Yeah, so as you can see from the previous updating demo, all VMs have been updated. So, okay, so first of all, I will show you the images and the rest a little bit later, but first of all, let's put some VMs into some images into the queue. So what the script does is pulls all the images from the all the names of the images from the bucket, then puts them into the queue so Autoscaler could pick it up. So let's take a look at images. So as I said, they are saved into the cloud storage. So let's go there. Open our project. And we have two folders. One is an input that has images that I've uploaded before the presentation. They were taken from the recent trip to the Italian Alps. As you can see, the images, the views were quite spectacular. And we have also an output folder that is empty. So let's go back to our manage instance group. And let's see how it is being set up. So we've turned on autoscaling as before, but this time, instead of using scaling based on the CPU, we've set up scaling based on the stack driver monitoring metric. So what we are looking, and what is important here, is that we are looking at the number of undelivered messages into the queue. The rest is basically not an interest in this now, and we have to provide the subscription name so the autoscaler would know which queue to watch on. And also, what is important, that you can specify the number of tasks per VM. So what does it mean? Is that autoscaler will take the number of tasks into the queue, divide it by the number of tasks that each VM can process, and then spin up the VMs to process this task. So if you have 10 tasks and you have 2 tasks per VM, you will have 5 VMs in the end. So let's go back to the autoscaling. Yeah, let's refresh. And as you can see, we have 5 VMs processing our images. So we can go back to the queue, to the storage. And let's see if there are any images processed. Yep, it's already working. And as you can see, we apply the watermark, like the GCP Next logo, and everything is up and running. Can we get back to the slides, please? Yeah, so, and we have also another tip for you. So you can reduce the cost of your service using the preemptable VMs, which can be up to 80% cheaper than the usual VMs. But there is a caveat. There are usually preempted, the VMs last up to 24 hours. That can be preempted in any time. But also our AutoHealing works with them. So AutoHealing, if the VMs will be brought down, the AutoHealing will watch for the capacity of preemptable VMs. If the capacity becomes available again, it will bring up the VMs again. And also one thing to note, that these VMs will be brought down gracefully, so we'll get a 30-second notice, so you can run your script, for example, on a VM and save your workload on a disk, or gracefully close all the connections.
So let's bring it all together. We have deployed an application in a container to a managed instance group. We have also built a highly available and scalable application with the help of AutoHealing, multi-zone deployment, autoscaling, and also can update it safely and automatically. And we have built a scalable batch pool of workers. Now, to finish, I want to leave you with this. If you need to deploy an application to multiple virtual machines and have full control over your applications, you don't need to do everything by hand. You can build a highly available and scalable application by combining the automated features of the managed instance groups that work for you. You're not left on your own.